Let's look at a simple example of actually doing this sort of uncertainty calculation. So we'll take the case where you've got some cylinder and you know the diameter with an uncertainty and you want to know the area with an uncertainty. So area is pi over 4 d squared. Okay, so we know sigma d, the uncertainty in d. What's the uncertainty in A? Well, we can do it in two equivalent ways, which will give the same answer. One way is to do it from first principles and just use the fundamental equation, which is the uncertainty in A is dA by dd, the uncertainty in D. So d area by d diameter, differentiate this, is just pi over 4 times 2d, which is just pi over 2d. So you get sigma A equals pi over 2d sigma d. That's one way to do it. In this case, it's a very easy way. Another way to do it is to do it step by step using the equations we've just talked about. So now the reason we're telling you about this, it's more complicated in this case, but it also allows you to handle things where you can't use the differentiation method, like when you're adding two variables. So often it's necessary to do the step-by-step approach. In this case, we saw there's an equation for doing the uncertainty when you raise something to a power, and there's also multiply by a constant. So if we go back to our equation here, you've got d squared times a constant, pi over 4. So what we can do is first of all work out the uncertainty in d squared using the raised to a power, and then we can pi over 4, d squared by multiply by a constant. So now raised to a power, if you remember, it's the fractional uncertainty in the result is equal to the fractional uncertainty in what you measure times the power law index n. So the uncertainty in d squared divided by d squared is equal to the power law index, which is 2 because it's squared, times the fractional uncertainty in d. So you rearrange that, you find the uncertainty in d squared is just 2d times the uncertainty in d. Okay, that's got you halfway there, and now you need to work out multiplying by a constant. You're multiplying by pi over 4, which is a constant, and in that case we know that the uncertainty in the result is just the constant times the input uncertainty. So as A equals pi over 4 d squared, sigma A equals pi over 4 the uncertainty in d squared. We've worked out the uncertainty in d squared up here, so it's pi over 4 times 2d sigma d. Factorize, and you get pi over 2d sigma d, which is the same as we got via the calculus method. So you can do it either way, both fine.